today we're going to be focusing on all the properties of rectangles. Okay? So right now, in your journal, what you should have written down is, first of all 5 properties of a parallelogram, plus all the angles are right angles, and the diagonals are congruent. What I'm not making you write is rewrite all the 5 properties of a parallelogram. But those are all the properties of a parallelogram. So all of these are part of a rectangle. Okay, you already have those in your journal. A rectangle is a special type of parallelogram. That's what you need to understand. Okay? So right now I'm going to draw a little rectangle right here to the right. We're going to go over some of these properties. So I have a rectangle right there. All right? And I'm going to look at your rectangle on your page because it has a P, it has an O, an N, and then an M. And it also has some diagonals that run from M to O and from P to N. So right here where it says diagonals are congruent, one of my diagonals is from P to N, and that is going to be congruent from M to O. So this diagonal is the same distance as this diagonal. That is a special property that's only in a rectangle. Okay? So that's one of the properties that are rectangles. Also, it says all the angles are what? Right angles, which means that's a right angle. That's a right angle. That's a right angle. And that's a right angle. So we have 1, 2, 3, 4 right angles. Now we should remember already that opposite sides are congruent. That's one of the properties of all parallelograms. Opposite sides are equal. So we know P to M and O to N are the same. P to O, M to N are the same. So we know opposite sides are equal. But here's something that's also different. Right here, that middle point, okay, that's going to be pretty important because that means that right here, these are bisected as well. So all of these, you'll notice I'm doing the exact same color. What does that mean? I'm going to put R right here. That means I have 4 segments that are perfectly congruent to each other. The distance from P to R is congruent to the distance from R to N, from P to R, R to N. Also, we could say that's congruent to N to R, which is congruent to R to O. Yes. Write those down. If you write those down, you'll understand you have 4 segments that will always be congruent to each other when you do what? When the diagonals are bisected. All right. If we have sides that are congruent, we're also going to have angles that are congruent. Okay? So right now, what I'd like you guys to do, label all these angles right here, all these angles in blue. Those are all congruent to each other. We're going to say from P to O to R is going to be congruent to triangle N to M to R. In addition, this angle right in here, these are also, wherever I'm coloring in green, all these angles are also congruent. Okay? So every angle that I'm coloring in green, these angles also match. So you'll notice we have 2 different triangles right over here that are going to be congruent to each other. So if I go from P to R to M, that is going to be congruent to triangle N to R to O. All the angles and all of the sides are going to perfectly match each other. And the triangles POR, NMR, PRM, and NRO. So these are all congruent to each other. So make sure you have all these angles colored the same. You have two more sets of angles. This angle here and this angle here. These are called vertical angles. Vertical angles are always equal to each other. So let's shade those in the same color. And these two angles are also vertical angles, which means they are equal. Something you need to be aware of is that you have 1, 2, 3, 4 triangles. All right, hopefully you can see that these triangles are the same and these triangles are the same. But every single triangle adds up to what? Adds up to 180. So let's just make up some numbers for your notes. We're going to make up some numbers. So let's say, for example, right here I said this angle right here was 20 degrees. If I said that was 20 degrees, that means every single blue angle would equal 20 degrees. Now, what is the blue and the green? What do they have to add up to because it's a right angle? Nope. Nope. Yes. A right angle always equals how many degrees? 90 degrees. That's right. So right here we've got a 20, so what does that have to be?
60.
Close.
70.
Here you go. So that's got to be a 70. That's got to be a 70. That's got to be a 70. So that's got to be a 70. Just remember, the green and the blue always have to add up to 90 degrees. All right? Why? Because it's a rectangle. And what do all the corners of rectangles have to be? All the corners of a rectangle have to be 90 degrees. All right. So now, we've got a 70, we've got a 70. What has to be the orange angle? The 70 and 70 and one orange angle have to add up to 180. Yeah, that's got to be a 40. And that's got to be a 40. Okay? If that's a 20 and that's a 20, that has to be 140. You're right. All right. When I say straight line, you say 180. Straight line. 180. Straight line. By the way, you guys see this straight line right here? What does 40 and 140 add up to? 180. So notice, what does this purplish color and this orange color have to add up to? 180. No matter where you look at it. 140 and 40. 40 and 140. 140 and 40. They all have to add up to 180. So there's multiple ways. Once you find one, all I technically have to do is give you one angle. And you should be able to find everything else. Okay. All right, now it's time to start solving some problems. You have the notes down. Okay? So I'm going to zoom out. All right. So here we go. We have a quadrilateral. It's in the shape of a what? Rectangle. I'm going to highlight MO. MO is this distance from here all the way across. I'm going to highlight PN. PN is this distance all the way across. What can you tell me about the diagonals of a rectangle? They're all congruent. Which means this, Jacob. Which means you can be sure that the distance from P to N has to be the same distance as from M to O.
So you only have to solve one.
Yeah, once you find one, you got the other, right? Yep, I would. So here's what I want you to do. I want you to set this equal to this, and I want you to solve for x. Go ahead, on your own. Solve for x. That's step number one. Step number one, solve for x. Step number two, plug x back in. Like back in where? Right here. Or here. Okay? And if you do that, you will find the distance from P to N or from N to O. And last but not least, you need to find the measurement from N to R. By the way, N to R, everybody, is this distance from right here to right there. So good luck, see if you can figure it out. When you're done solving it, unpause the video, and then you'll be able to check to see if you got it right. All right, step one, we're going to solve 4x. Now, you don't have to do this. I'm just going to do this because this equal sign is pretty dadgum important. Whenever you're solving for x, you got to get all of the variables on one side of the equation and all of the numbers on the other side. So the very first thing I'm going to do, I'm going to take away 6x from this side and take away the 6x from this side. That's going to give you a 3x plus 5 equals, I'm just going to bring this 14 down. If I move all the x's to the left-hand side, what does that make me do? That means to move all the numbers to the right-hand side. And now, all I have on the left-hand side is a what? 3x, we've got zeros out. Equals 9. Very good. And then the final step is just to divide both sides by 3. And x by itself is equal to a 3. I guarantee you, if this was a multiple choice question, one of the answers would be 3. And if you chose that, it would be wrong. So now, we have two choices. We could use what? 9x plus 5, or we could use what? Right. So we could do 9 times 3 plus 5, or 6 times 3 plus 14. Either way, you get the same answer. 18 plus 14, 27 plus 5, that's both what? I guarantee you. Guess what else would be there in a multiple choice answer? 32. That would also be there. Okay? That's not your final answer. Why? Because it asks us to find what? The distance from, which is half the distance from P all the way to N. So you have to make sure that whatever this right here is, what are you going to have to do? You're going to have to cut it in half. What's your final answer? 16. So N to R, everybody, that segment was equal to 16 units. So just so you know, like I said, you're going to have an A, a B, a C, and a D answer choice in a multiple choice test. One answer would be 16, one would be 32, one would be 3, and then they just throw in a stupid answer. There's usually one stupid answer, they just throw in, a random question. Right? Off the wall. Just off the wall. Like, you can usually eliminate one of them, okay? But be careful. Just because you solve for x doesn't mean you got the answer right. You got to do what with it? Plug it back in. So now that we've done that, we're going to help you guys set up 19, 20, and 21. I'm not going to do it for you. I'm going to help set it up. So here we go. Number 19. N to Q is this distance right here. Q to N is this distance right here. What can you tell me about N to Q and Q to N? They're congruent. Why do we know they're congruent? Because all of these little segments right here, if we go back to our picture, all of these 4, remember we talked about all those 4 right here, we have 4 segments that are always what? Congruent to each other when you bisect those diagonals. So we know those are congruent. So the first thing we do is do what? Set NQ equal to QN. So I'm going to do that first. I set NQ equal to QN. Segment NQ is congruent to segment QN. What is N to Q? 5x minus 3. What is QN? 4x plus 6. So once again, step 1, what am I expecting you to be able to do? Solve for x. Step 2, lug it in. Lug it in. Now, what's that going to give you? That's going to give you the distance from here to what? Here to there. But this time you're going to have to do what? Multiply it by 2, because N to K is twice the distance from N to Q. So, I think you did this correctly. The first thing, if you wanted to move all the x's to the left, you probably took away 4x from both sides. Is that what you did?
How do you know?
How do I know?
No, like, because I was trying to take away or add 3.
You can't.
It don't matter.
Add 3 to this side, you got to add 3 to this side.
It don't matter which one you do first.
Nope.
Because you eventually going to have to do both of them.
So you can do them both at the same time if you want to. But you have to make a decision. I'm going to have all of my x's over here. I'm going to have all of my numbers on the right-hand side. So what is 5x? Take away 4x. 1x. What's negative 3 plus 3? 0. What's 4x minus 4x? 0. What's 6 plus 3? A 9, right? So all I have is what? I have x plus 0, and I have a 0, and I have a positive 9, which means x equals 9. So that's step 1. You had to find what x is equal to. That's the first one. What do I have to do with this number? I have to take wherever x is, and what am I going to do? I'm going to plug in a 9. So let's go back up to the equation. Ready? Right here. Plug it in. Well, where do I plug it in? Which one do you like, Jerry? Do you like 4x plus 6, or do you like 5x minus 3? Which one do you like? Either way, doesn't matter.
Sure.
Which one would you like me to plug it into? 5x minus 3 or 4x plus 6? Which one do you like better?
Let's do 4x.
Okay, let's do that. Here we go. So I have a 4. I have an x plus 6. But I know what x is equal to now. What is x equal to? I heard the buzzer. I'm not concerned. Yes. I am at the exit gate.
Okay, all right, thank you.
You betcha. 4 times what was my value for x? What is 4 times 9? 36. What is 36 plus 6? 42. Now, what does this mean? That means the distance from what? The distance from Q to M, which is this distance right here, everybody. From Q to M. What did we find that distance to be? 42. What's the distance from Q to N also going to be? 42. But this says find what? N to K. So what is the distance from N all the way to K? Well, if that's 42, what does this also have to be? 42. So what's all the way across? 84. So your final answer for number 19 is 84. So step 1, what did we do? We solved for x. Step 2, what did we do? We randomly chose. All right, Jarrett chose this one to plug it in for. Now, Jarrett, let me show you real quick. What if you would have chosen the other one? What's 5 times 9? Minus 3. That's 45 what? 45 minus, and still what? It's still 42. So it still would work. It doesn't matter which one you plug it into as long as you choose one of them. And then what did we do? We realized that all of these segments right here, all of these segments are going to be congruent. And then you find what you're looking for. N to K. So what is number 20? I'm going to zoom in right here. What does number 20 ask us to find? It asks us to find from what? So just from what? Just from here to here. But it says N to Q is what? 2x plus 3. Well, what do we know about the distance from J to Q and the distance from N to Q? What do we know? They're equal. Okay? What about from Q to K? And from K to N. They're all going to be equal. So this says NQ equals what? 2x plus 3. This says Q to K equals 5x minus 9. So I'm going to highlight this real quick. Here and here. N to Q, Q to K. N to Q, Q to K. What do we know about those segments? They have to be equal. So set them equal to each other. Set 2x plus 3 equals 5x minus 9. Set them equal to each other. What do I want you to do once again? Solve for x. Take the answer and do what with it? Solve for x, and after that, plug it in. All right? And guess what? Once you plug it in, you're going to have your answer. All right, Katie, tell me what you did. I like it. By the way, I'm going to ask you a question because that's what I did too. Why did you subtract 2x from both sides? It's easier. I would agree. It's easier because now we have positive x's on both sides. What did you do?
And then
Added 9, very good. So what right now, if you're not good at solving fractions, you need to look for a pattern. Why did she add 9? Because the only way to get rid of a negative 9 is to add a 9. That's why. By the way, does anybody know what those are called? A negative 9 and a positive 9, or a 2x and a negative 2x? There's a vocabulary term. They're called additive. Additive inverses. Additive inverses always get you to 0. So what would be the additive inverse of an A? A negative. That's an additive inverse. There you go. Okay? So right now, what do we have? We have 3x equals what? 3x equals 12. What does x equal? 4. And then what did you do?
I plugged it into 2x plus 3.
All right. So plugged it in. So she did 2 times 4 plus 3. What's 2 times 4 plus 3? 11. Boom, you're done. So JQ is equal to 11. Why? Because if N to Q is equal to 11 and Q to K is equal to 11, then J to Q is also equal to 11. Okay? So we're going to go over a couple more, and then you guys have some homework tonight. Okay? Oh, yeah. You're having homework. So right now, we are not going to do number 21 because number 21 is just like number 19 and just like number 20. We're going to do number 22. I'm going to highlight this angle right here in orange. I'm going to highlight this angle right here in green. So we're going to take a look at these. So right now, check this out. N to J to M. So I'm going to go from N. I'm going to go to J. I'm going to go to M. I'm going to highlight it right here in orange. That's this angle right here. I'm going to go from K to J to M. From K to J to M. Which means this angle right here. How do I know that's the case? Because what's the middle letter always have to be? That has to be your vertex. Okay? Now, are these angles exactly equal to each other?
No.
No. It's a rectangle, right? What do they have to add up together to equal? They have to add up to equal 90 degrees. Which means this angle, the orange angle, plus the green angle, have to add together to equal 90 degrees. This is how you set it up. 2x minus 3 plus x plus 5. What should those angles, when added together, equal?
Or 90.
90. Because every single corner in a rectangle is 90 degrees. So I don't know what those two angles are, but they have to add together to equal 90. What are you looking for? You're looking for the measure of what? N to J to N. By the way, I'm just letting you guys know, your answer is going to be a decimal. It's okay. So find x. Number 1, solve for x. Number 2, look at it. You'll notice right here, everybody, angle 1 equals 25 degrees. We did a question like this at the very beginning. If you go back and look, use this as a guide. Now, I didn't say 25 degrees. I said what? 20 degrees. So use 25 degrees right there and solve for all of your missing angles. One more thing real quick.